So we had defined rational numbers as P by Q, where Q cannot be 0 and P and Q can be any integers. But remember, Q cannot be 0. Now another way to look at P by Q would be P times 1 by Q. That is a multiple of a unit fraction. So this is how we define rational numbers. So now let's look at this number, which is 18 by 7. Now 18 by 7 can be looked as 18 times 1 by 7. That is a multiple of a unit fraction. Also, if you remember that whenever we have a rational number, what does the denominator tell us? The number of parts in which we should divide our unit length into. So we have this as a unit length. Denominator is 7, which tells me that the unit length should be divided into 7 equal parts. So I have this unit length and I divide it into 7 equal parts. 1, 2, 3, 4, 5, 6, 7. Similarly, this is also a unit length from 1 to 2. I divide that also in 7 equal parts and so on. Every unit length can be divided into 7 equal parts. And what does the numerator tell me? The numerator tells me the number of such parts. So numerator here is 18. So 18 such parts. So this blue line actually indicates 18 of such parts. 18 such parts gives me 18 by 7. So this blue line is actually the length of this number, which is 18 by 7. Now, what is unusual here? So far, we had seen that fractions were number less than 1. But here you see that it is actually greater than 1. And not just 1, greater than 2 also. What is the difference here? That the numerator, which is 18, is a much larger number than the denominator. And whenever the numerator is greater than the denominator, I call that fraction as improper fraction. And improper fraction would always be greater than 1. So improper fractions would always be greater than 1. So now let's look at this number 18 by 7. So this is this blue line 18 by 7. But what is this number trying to tell me? Where is it positioned on the number line? So I have 2 units and 1, 2, 3, 4. 4 of these 7 divisions. So what I can say is 2 divisions, 2 whole numbers, 2 units plus 1, 2, 3, 4. 4 of 7. Because this unit length is divided into 7 parts and 4 of such parts. So this number I can also write 18 by 7 as 2, 4 by 7. 2 units, 1, 2, 3, 4. 4 by 7, which is a mixed fraction. Now why is this a mixed fraction? Because it has an integer. There's an integer part which is 2 and there's a fraction part which is 4 by 7. So I can write 18 by 7 as 2, 4 by 7. Now this way of writing it is called converting fractions. I have converted an improper fraction to another type of fraction which I called as mixed fraction. Now how do I actually do that? Let us see. I want to write 18 by 7 as a mixed fraction. How will I do that? Remember that fraction is same as division. So I can write 18 by 7 as 18 divided by 7. So if I divide 18 by 7, 7 2s are 14. That leaves a remainder 4. Now look at this number here. You can see that the divisor 7 is still the same. What does this 2 represent? This 2 is the quotient. And what about this 4? 4 is actually the remainder here. So if I divide this, 2 is the quotient, 4 is the remainder, and the denominator remains the same. That is, here if I divide 18 by 7, then 7 is the divisor, 7 still remains the divisor here. So what I can see is that if I have an improper fraction and if I see this improper fraction as something divided by something, as a division problem, then 18 is a dividend, 7 is the divisor. So I divide 18 by 7. What I see is that in the mixed fraction, The integer part is actually the quotient which I get on dividing 18 by 7. 4 is the remainder and 7 is the divisor. So that's how you can convert an improper fraction to a mixed fraction. So now can you convert this number to a mixed fraction? What I need to do is, I need to divide 22 by 5. So divide 22 by 5. 5 fours are 20. What I am left with is remainder 2. So I can write this number as, now for the mixed fraction, the integer part is the quotient, which is 4. Numerator of the fraction part is the remainder, which is 2. 2 is the remainder here. And the denominator remains the same, which is 5, the divisor. So 22 by 5 can be written as 4 2 by 5 in the mixed number format. So that's how I can write it. Now I've seen how I can convert improper to mixed. Now can I convert this mixed number back to improper? So let's look at this mixed number, which is 2 4 by 7, which is represented by this blue line. So this blue line actually represents this number, which is 2 4 by 7. 2 whole units, 4 by 7, that means if I divide this unit length into 7 equal parts, 4 such parts gives me 2 4 by 7. Now I want to convert it back to improper fraction. So first thing is, how many 7s actually fit into this entire number? Now if I divide, for that I need to divide each unit into parts of 7. So this would have 7 parts, this would have 7 parts. So 7 parts plus 7 parts, that is 14 of such 7 parts, and plus 4 more 7s. So let's look at this. So I divide this, each unit length, into 7 parts. How many 7s does this 2 have? 14. 7 plus 7. So 14 by 7. And here I have 4 by 7. So this number, mixed number, which is 2 4 by 7, is nothing but 14 by 7 plus 4 by 7. So this blue length is actually equal to this 14 by 7 plus 4 by 7, which is equal to, since the denominators are the same, this is 18 by 7, which is an improper fraction. So 18 by 7, we back to the improper fraction from the mixed number. Easier way is that, remember, how did we get this number? 2 4 by 7. 2 4 by 7 means 2 plus 4 by 7. So it is 2 units plus 4 by 7. So remember that this mixed number shows 2 plus 4 by 7 and not 2 into 4 by 7. 2 into 4 by 7 would give me 8 by 7. So this is not equal to 8 by 7. So this is not 2 into 4 by 7, it is 2 plus 4 by 7. If you remember this, then you can easily convert it back to improper fraction. You can add these two numbers. You can write 2 as 2 by 1 plus 4 by 7. Now you have two rational numbers and you know how to add these rational numbers. Taking LCM, making the denominators same, you can add these two numbers, which gives me 18 by 7, the improper fraction. So that's how you can convert a mixed number to an improper fraction. If I look it as this, that is division. If I look at the fraction as division of two numbers, then this is dividend, divisor, and we'd seen how to convert improper fraction to a mixed fraction. Now what I want to see is, how do I get back from mixed to improper? So I know the quotient, I know the remainder, I know the divisor. What do I need to know? The dividend and the divisor. So divisor, okay, I know the divisor because here the divisor is the same. What I need to find is the dividend. So from quotient, remainder, divisor, how do I get back to the dividend? Remember that dividend is nothing but quotient into divisor plus remainder. Dividend is quotient into divisor plus remainder. So 7 twos are 14. Add 4 to that, which is 18. 18 by 7 gives me back the improper fraction. So now, can you convert this number 2, 3 by 5 into an improper fraction? Let's see how to do that. So we have 2, 3 by 5. How would I find the dividend? 2 into 5 is 10, plus 3, 13. So 2 into 5, 10, add 3, 13. So this is 13. Divisor here is 5. So divisor remains the same, which is 5 again. Another way is, you see 2, 3 by 5. Look at it as 2 plus 3 by 5. If this is 2 plus 3 by 5, then you can simply add this. 2 by 1 plus 3 by 5. If I make the denominators the same, which is 5, then I get 10 plus 3, which is 13 by 5. Same improper fraction again. So these are the two ways in which you can convert the mixed number or the mixed fraction to an improper fraction. So we've seen how to convert an improper fraction to a mixed fraction. We've seen how to convert a mixed fraction to an improper fraction. But why do we do all this? What is the need? If I look at the number 18 by 7, can you just figure out where this number would be on the number line? Looking at 18 by 7, it does not give me any idea. But look at 2, 4 by 7. The mixed fraction is way easier to interpret on a number line. I know that this is a number which is greater than 2 because it is 2, 4 by 7. So this number would actually lie somewhere between 2 and 3. It is a number which is greater than 2. So mixed fractions are easier to interpret, whereas improper fractions are easier when I use it in arithmetic. When I need to calculate sums, solve sums, then improper fractions are much easier. Let us look at this. Now if I give you two mixed numbers or two mixed fractions and I ask you to multiply, it actually looks quite complicated. Which numbers do you multiply? Clueless. So rather than these mixed numbers, improper fractions here help us. What I need to do is, I need to convert these mixed numbers to improper fractions. Then I can easily solve it and then convert it back to mixed fraction if required. So this would be 1 into 7 plus 2, which is 9 by 7. This would be 2 into 5, which is 10, plus 1, 11. 11 by 5. Now I easily know how to multiply these two rational numbers. I multiply the numerators, which is 99. I multiply the denominators, which is 35. So I get a fraction here, which is 99 by 35. Now again, this is an improper fraction, so I can convert it back. How would I do that? Divide 99 by 35. 35 twos are 70. What I'm left with is 29 as the remainder. So this can be written as, what is the quotient here? 2. What is the remainder? 29 by the divisor, which is 35. So these two mixed fractions can be multiplied and the answer is again a mixed number, which is 2, 29 by 35. So that's how you can convert improper to mixed or mixed to improper whenever the need may be.